So thanks for joining. This is our January meetup, first of the year. And today we have with us Sebastian from the Compute Software Group. And Sebastian will be talking about getting started with the HPE GreenLake for Compute Ops Management APIs. Before I hand it over to Sebastian, I would like to advertise some of the things we have prepared for you in the coming month. As you know, this is a meetup, but we have another program called Munch and Learn, which is also a monthly program. So we run the Munch and Learn typically on the third Wednesday of every month, and the meetup on the last Wednesday of every month. So if you want to remember that, that's an easy one. So we have a couple of options for you in the coming months. For February, we have a Munch and Learn on generative AI by a group of our experts from the Office of the CTO, and they'll be talking about secure Gen AI adoption for all. And what's behind that is our codename Project Eton, and we have started discussing at Discover in Germany. No, sorry, in Barcelona, and they'll be giving a lot more details about this project on February 21st. So that's one. And for the meetups, so follow up on this particular session from Sebastian. We'll have in February a session on Aruba Central automation done by our colleagues from Aruba, Alvin and Kartik. And then in March, we'll have the HPE dev team. So that's me and my colleague Denis and Fred and Mathieu here in the call. We'll be talking to you about the GreenLake platform APIs, which were recently released. And we'd like to explain and show and demonstrate the capability. That's going to be March 27. So that's what we have in the pipe for these two programs. You can find on these links, not only the registration links, and I know they will be pasted by Denis and the guys in the Q&A. And they are actually being pasted right now. And but also you find all the replay from the previous sessions. For example, last week we had a Munch and Learn with Don Wake on GreenLake, building a private cloud with GreenLake. And this is we just posted that on the Munch and Learn page together with the PDF of the slides and the replay link. So you can, if you missed it, you can go and check it out. So that's for webinars, but we also have another section that you might find interesting called the Workshops on Demand, and you can check out the link here. It's basically a catalog of workshops where you can learn on your own and have a little bit of hands-on experience. We use Jupyter Notebooks as an experience. This is available, and that's the nice piece. It's available 24/7. It's available on the internet, so it's available to everyone. And it's also free. So feel free to take a look at the catalog. There are things such as what's a REST API, simple stuff like that. You have Docker 101, you have Kubernetes 101, you have programming languages 101 like Python and Rust. So there's quite a fair amount of things that you can learn from these workshops. Give it a try, and if you do give it a try, provide feedback. There's a survey at the end of each of these to give us feedback, what's missing, what you'd like to see, what you like and what you didn't like. Again, we run this program. It's a community, so it works only if you help us amplify and if you contribute. So if you like our talks, feel free to invite others to join the talks. Remember, these are open to everyone. So family, friends, colleagues, students, customer, of course, and partners are more than welcome. So don't hesitate to invite if you see people have a good match with the topic of the month. We also have a newsletter that we issue every month at the beginning of every month. So you can sign up for that, and you'll be sure that you don't miss any of the upcoming sessions. That's a good way to keep track with some of the blogs that are being published and some of the talks. We have a dedicated Slack that we maintain and we pay for. It's a different Slack than the HPE internal Slack. So this is open again to external, and we have channels for almost all the dev I would say, topics within HPE. So you can help a customer there. You can ask questions yourself. So feel free to join and engage the conversation there. If you're more like a X or Twitter, I should fix that. It's now called X. We have a handle for the HPE developer community that you can follow to keep track of what we do. Finally, if you're an SME, subject matter expert on a given technology, open source, something HPE, we will be always very interested in getting more blog contributors. So feel free to reach out. We have actually a guide to help you through building a blog. We use GitHub, we use Markdown and rich text format. So it's pretty straightforward. And I would say within a week, we should have your blog published on the website. So reach out to us. We also are looking for speakers for meetups. Also, we are looking for contributors when we go to an event. For example, when we do the Hack Shack in HPE Discover, we're always happy to host additional participants. And finally, if you want to build with us a workshop on demand because you think there's a gap and you can help, feel free to reach out to us. And we'll show you what we have as a framework and how you can plug additional content in it. So that's one way to, that's all the links that I more or less you can, are touch points if you want. That's the external Slack. This is the internal Slack. We also have one for asking questions within HPE, but that's the newsletter sign up. We have also a generic email mailbox. We have a YAML group for partners, and this is a direct link to our workshops on demand. There's a QR code that you can scan for all these links. Feel free to do that. So that's it for me. If you, let's get started with Sebastian and the real content and computer ops management. Thank you very much, everyone.
So hello, good morning, good evening, good afternoon, everyone. We're going to be talking about getting started with HPE GreenLake for Compute Ops Management API. My name is Sebastian Chagara. I'm a principal cloud developer in the Compute Software Group here at Hewlett Packard Enterprise. I've been with HPE for about 15 years now. I started out working on a product called HPE Virtual Connect, moved on to HPE OneView, and for the past 3 years or so, have been working on HPE GreenLake for Compute Ops Management. One of the things about the product is the lengthy name. So on the development side, we often refer to it as COM, but I'm going to do my best today not to do that, but I may slip up once or twice. The other thing that I'll add is, since we have an audience for employees and other partners and customers as well, that throughout the presentation or through Q&A, we may talk about features or functionality that may be coming up. But I'm not making any guarantees or promises about when that functionality will show up or if it will show up. So please don't mistake that for any promises or guarantees on our part. Just getting that out of the way before we get started here. So with that out of the way, let me kind of talk through the agenda that I have for our meeting today. So the first thing will be getting started. They're kind of going over a few links of where we can get started with GreenLake Compute Ops Management. I want to talk about some API features as well. Then talk about some of the Compute Ops Management resources that we have. So a little introduction to the different types of resources that are available that we can manage with the API. Then I will do some demos so that we can actually see and get a hands-on look and feel at the API. And then there will be time for Q&A at the end. And so before I want to get started here, I want to get to know the audience a little bit better. So I have a couple of questions, a couple of quick polls that we're going to do here at the beginning. So the first one's going to be, how frequently do you use any of the HPE GreenLake APIs? So this doesn't have to be specific to Compute Ops Management. This can be any of the HPE GreenLake APIs, whether you use those sometimes, not using them monthly, weekly, daily, etc. So please go ahead and vote. Got almost half the participants voting, which is great.
Let me know when you want to stop and share the result, if you want to share them.
Yeah, I think we can go ahead and stop and share the results now. We're about 70% participation. That sounds good. Yeah, so as we can see, right, we've got a few users that are using them occasionally. So that's really great to see that there's already some familiarity and experience with some of the GreenLake APIs. For those of you that don't use them yet, this is great. So this will be a great opportunity for you guys to get started and learn more about those APIs, and particularly for compute ops management. The next thing is a second poll that's a little bit more specific for compute ops management. So have you ever used the HPE GreenLake for compute ops management API? And here I got to explain the answers a little bit. So if you don't have a GreenLake account, it's hard to use the APIs. So that would be one option. If you don't have compute application provision, then it's also difficult to use the APIs. So you might fall into one of those two categories. But if you do have compute provisioned or have an account and compute provisioned, then it's kind of a yes or no question. So we can go ahead and go to the second poll. Or were they both? Oh, they both ran at the same time. I see that now. Okay, sorry about that.
Yeah, sorry, I put the two questions together.
Yes, okay. I had to scroll down to see the answer for the second one. Okay. Okay, so a good mix there of, again, not having an account or not getting started. Okay, great. So I'm gonna hit stop sharing on that. Close this. Then let me go ahead and switch to the getting started slide here. Okay, so these are a few links where we can get started. So the first link here is going to be for learning about HPE GreenLake for Compute Ops Management from kind of our public marketing facing perspective. So if you're not sure what the product's doing for us or how this is working within the ecosystem that we have within Compute, you can learn more about the product there. If you're already familiar with that and have kind of created an account and have Compute launched or ready to go, the Compute Getting Started guide is a great next resource that I would recommend to learn more about what we can do with the product. And then the other three links are going to be kind of the most interesting for today. So there is a HPE developer portal where there's a section for compute ops management as well. This contains a number of blog posts that we've done over the past couple of years on different topics, including getting started with the API, kind of a very quick intro, 5-minute getting started guide, and some other topics. Then there's the HPE GreenLake developer portal, which I'm going to take a look at in a second, where our API documentation is hosted for all of the GreenLake APIs, including compute ops management. And then the last link here is going to be a direct link to the HPE GreenLake for compute ops management API documentation, which we'll definitely be taking a look at in more detail today. So let me switch to my browser and kind of show these sites. So again, this is the GreenLake developer portal. Here you have kind of three main sections. We can see the guides, services, and then a link to the developer community, which was the other one of the other links that we had on the slide there. So if I click on through to services, then we will see the list of services over here that are available currently from GreenLake that have APIs published. So compute ops management is kind of the main application that has a published API currently. The other published APIs here are for general GreenLake management for your GreenLake account, where you get things like devices, subscriptions, identity access management, things like that. So I'm going to switch over here to this tab, which is the compute ops management API documentation. And here we can kind of see what we have to offer about our API. So there's an overview, guide, glossary, sections on event webhooks, job definitions, and our API reference. And I'll go into those in a little bit more detail kind of throughout the presentation. But the quick summary is in the guide, we see some of the basics that we're going to need later on. So we see our endpoints here where we can, our API endpoints for the different regions. So depending on which region you deployed, provisioned your application into, that will be the region that you use to communicate with that instance of compute. So here are the kind of the three API endpoints that we have. There's a section kind of on making it work, gives you kind of an introduction on how to make a successful API call, and some information on filtering that we're going to get back to. The glossary is going to contain a list of terms that you may want to know about because we have, maybe there's some terms that we use in a different way or a specific way within this application. So that's where you can find out more about that. We'll talk about event webhooks later and job definitions. So I want to focus on the API reference right now. This is our main API reference. And this is where you get all the nitty-gritty details about our API. So it starts with the Open API specification, which you can download here in its entirety as a JSON file that's with the Open API standard. And then you can also browse our API directly here on the portal. looking through all the different resources we have and the versions that they're at. And we'll talk about some more of those resources throughout the presentation. And then the last thing I want to point out down here is the change log. That can be useful to reference is as we make changes and publish new APIs, we keep our change log updated to kind of describe the changes that are happening, because it's not always obvious what changes have recently gone in. So for example, back in the end of November, we added the webhook and eventing sections APIs. So that was kind of published at that point in time. So that's kind of a quick overview and kind of an organization around that. I guess the one thing that I should get back to is kind of a quick description for compute ops management. So this is providing you, we're going to actually go ahead and switch to the getting started guide. So, compute ops management simplifies and unifies your operations across the server lifecycle for the whole environment, no matter where your compute infrastructure lives, providing a consistent, secure cloud experience that scales elastically and unifies compute management. And yes, I just read that, but as a developer, I don't have that memorized, so it's easier to just read through that. So the Getting Started guide provides you a list of the features as well that you can go take a look at to see what we offer. But I'm going to assume some familiarity here, and we'll kind of see how the features come together as we go through the rest of the presentation and the resources. So with that, I'm going to switch back to my presentation, and let's talk about some API features. So I want to start with the API features because these are some common things that you're going to see as we kind of go through and use the API. And hopefully what you'll see is that these common features on the API are kind of standardized across all of HPE GreenLake APIs. There's a lot of work going on behind the scenes on creating a standards-based API for all of the GreenLake services, and that's what we've done with compute ops management. And I know the other GreenLake services are working on that as well. So a lot of these features that I'm going to be describing here are things that you'll see again and again as you're interacting with the HPE GreenLake APIs. So let's kind of start with some basics, right? What is kind of our URI path? What does our versioning look like? So here we have an example URL for the compute ops management API. So we can see compute ops is kind of the first part of the path. Then we have this string, which is a version string. Then we have groups, which is going to be a resource collection, and then a UUID, which is going to be a unique identifier for a specific instance within that resource collection. So in this case, a specific group. And our versioning strategy, there's actually a page on the developer portal describing the versioning strategy and explaining what that would mean. So I'll touch on a few highlights here and then kind of point to that for more details as you want to read about that. So I guess before we get to versioning, the URIs are composed of an API group, so that it would be compute ops. Then there's the version string, the resource collection, and then so on. So each of the GreenLake APIs have their own API group. That's kind of how you, logical groupings of APIs are grouped together at the API group level. It's sort of a namespace if you want to think about it that way. And then the versioning strategy is going to be custom to each resource collection. So as the resource collection evolves, and goes through kind of iterations, with introducing, maybe breaking changes, new functionality that may cause a new version to appear. So versioning stages, there's 3 versioning stages. We have alpha, beta, and stable. And here we see some example URI paths for the different versioning stages. So the alpha one has kind of the least guarantees in terms of its performance and how long there is between versions or what kind of breaking changes we may make. So that one's kind of, as alpha implies kind of in the software world, is maybe not something to rely on a lot, but is kind of an example. Alpha things may go away at some point too. So that's kind of the least stable of the versioning stages that we have. Beta is going to be a significant step up from alpha. So here the APIs are definitely usable. They're no longer toys, as we like to say sometimes, and these can be relied upon. I think there's a 1-month kind of deprecation notice. So we give 1 month notice before a beta API goes away, and there should usually be a suitable replacement as well. And we avoid breaking changes. So as we go through the different beta versions, we try to not, you can make breaking changes from one version to the next, but not within a version, which is maybe not true for an alpha API. And then stable is kind of the most stable that has expected and explicit performance guarantees. There's a 6-month notice period before we can deprecate and sunset a stable API. And so that one's kind of the most, the highest version stage that an API can reach. So just quickly describing kind of how the string gets put together. So V1 across all of these is kind of the major version. And then for alpha and beta stages, you kind of have the alpha X or beta Y string after that. So those are subversions. So the way this would go, if we needed to version this resource and we wanted to stick with the alpha version stage, this would be V1 alpha 3, V1 alpha 4, etc. We would probably not get to a V2 until it maybe got promoted to stable, and then we might start a V2 alpha. So the major version really happens kind of for major changes. The minor versions kind of iterate through as we make tweaks to the API. And beta is going to be similar. We're going to go to beta 3, 4, 5. And at some point we would go to stable. But on stable, we're not really going through the versions very quickly, again, because of that 6-month deprecation policy. That's kind of going to slow things down a little bit. But that's kind of it on the versioning stages. And I will quickly switch back to my browser window. So if we look under the guides section, that's where we can see the API versioning basics. So if you come in here, you can read more about the different versioning stages and kind of what guarantees are associated with each, to just kind of learn what the expectations are from our side and the expectations from your side when using the API. All right. So let's move on to some common properties. So here we have an API. All of our APIs have some common properties when we get to our resources. And these common properties are all included in the compute ops management resources. And you'll see a lot of these across other APIs as well. So the ID and type are going to be required common properties for just about any resource that we have. And the type is a combination of that API group that we saw and the resource type. So it might be like compute ops / server. Then we have a set of properties here with generation created at and updated at. These are going to be required except for dynamic resources. So if we have resources that are not dynamic, that are maybe stored by a persistent data store, such as a database, they're going to have a generation, a created at and updated at. So the last two are timestamps of when that resource was created and most recently updated. Generation is going to be an monotonically increasing integer to indicate that increases each time that resource gets changed. And then the last three are going to be resource URI, name, and tags. So all properties might not have these three properties, especially tags. Only some of our resources are supporting tags at this point. And a lot of resources are going to have a name. That's a pretty common thing we see, especially for resources that users are creating. We may have names. Otherwise, a name might not always be reasonable or necessary for all resources. And then resource URI is a self-reference to that resource. So that is the path that we saw previously with that group. That could also be a resource URI for the group itself. So just kind of a reference back to that resource itself. And those are, I guess, strictly speaking, optional. But again, most of these common properties are going to be included in all of the resources. And as you look through our API documentation, you'll see exactly which properties are included in each of our resources. But these are kind of some of the common properties that we have. So next, let's take a look at a couple of query parameters. So we have query parameters that might be supported on some of our resource collections. So this would include things like sorting and filtering. So we can sort a resource collection in ascending or descending order using one or more properties. And in this example, the name, comma, created at ASC string is going to actually sort on two properties. We're going to sort on a name first, and then by created at an ascending order for created at. Name is going to be the default sort order, which might be descending or ascending, or ascending. It kind of depends on the API. It should have that documented. Filtering, this allows us to use a query language that's based on OData 4 and the grammar behind that to filter resources in a resource collection. So if we have a collection of resources, whether it's servers, groups, storage devices, whatever it might be, we can go ahead and filter on those. And here's where I definitely encourage you to see our guide in the filtering section for more details and examples. Because unless you're very familiar with OData 4, you might want to take a look at those examples and see exactly how we're using that query language and what some of the examples are and how you can successfully build a filter query. So here's a very simple example where we have a property equals some value here, a string literal. But there's far more examples in the guide. And again, let's switch to that real quick just so we can see that example, or just kind of describe what we see here. So, we kind of go through and describe the filtering primitives. So let me make this a little bit bigger here, so maybe easier to see. So the comparison operators that we support, how modifying string operators, The nesting separator is actually an important thing to highlight. So as you're dealing with properties, it may be possible that that you're not filtering on a top level property for a resource. And so instead of using the period as a separator, the nesting operator is actually a forward slash. So you might have something like health slash overall status might be a property that you might be filtering on. Data types that are supported, logical grouping with parentheses, and then not and or are possible. And so here's an example kind of our nesting strategy. And then we just use examples kind of outside of our domain, at least initially, to describe the operators, some of the special cases with string management, describing literals, a little bit of URL encoding, right? So I'm not going to go through all these details because it would just take way too long, but just want to show this up here so that if you're working on writing some filters, you can come back and reference this to make sure you can create a successful filter query. So here we kind of show some examples, again, with kind of like names and ages. So it's easy to relate to, but kind of showing you the order of operations here and kind of how the filtering language works. So that's the documentation we have for filtering. So the next interesting piece for API features I want to talk about is pagination. So we have resource collections, and resource collections may implement offset-based pagination. In fact, most of the resource collections that Compute Ops Management has are implementing offset-based pagination. And for that, we have a couple of things that support this, both in the query parameters and in the response. So the query parameters are going to be offset and limit. So the offset is going to be the zero-based offset that we have for the offset-based pagination. So starting at 0 or 10, wherever you may want to start with that resource collection. Limit is going to determine how many items you're asking for or requesting in the response. So it might be a page size in some other context as well. But offset and limit are kind of how you can control where you start, how many resources you want to collect to allow you to kind of page through that resource collection. And then in the response, what you're going to get back is a total, which is the total number of items in the result set, the offset for the return page, the count of the number of items, and then the items array, which is the actual items. So the length of the items array should be the same as the count. And then for total, it says the number of items in the results set, which is specifically phrased that way because the results set might not mean all of the resources in that collection. And the reason is the query parameters that we were just talking about, specifically filtering. So if you make a query against an API and you don't have any filtering applied, then total, which should be the full resource collection for all the resources that you have access to and are scoped to, for example. But if you have a filter applied, then total will reflect the total with that filter applied. So if you're only looking for filter resources with a specific name or a specific type, or I guess a specific subtype or maybe a specific attribute, then that's where you're going to get the total from. And then offset and count, will still reflect kind of what the current page that you're looking at. So that's it on pagination. The next thing is going to be error responses. So error responses are going to be standardized across all of our APIs as well. And the standard error response contains an error object. And this is also, again, described in our API documentation. So as you go through each API and you look at the error responses for, the 400 type errors, bad requests, retries, things like that, you'll see kind of the same error object again and again, which is why I want to highlight here what the components of that are. So the error object includes the HTTP status code in the response. There's a unique machine-friendly but readable error identifier. So this is kind of a unique error code for that type of error. There's going to be a message so that you can read and get a description of what the error is. There's a debug ID, which is like an instance of this error. So the error code might be the same as you make, if you make the same call and it results in the same error, it might be the same error code, but you might get back a different debug ID, which can be useful if you're contacting support and need help with that. That can help us on the development side, maybe track down that issue in a little bit more detail. And then lastly, there's an object included in the error object with additional details. So error details provides additional information about the specific error that you've encountered. And so here, this may have different forms. There's kind of a bad request variant of this, a retry variant, and general metadata variant as well. So I want to kind of point out a couple of these in our API just to see what those look like in our documentation. So let's go back over here and we'll just take the activities API. So we can see here in the activities API that the query parameters are listed here. So you can see offset, limit, and filter as query parameters that are provided here. And again, with filtering, we provide a little bit of information here to kind of get you started and have some helpful reminders on like encoding. And then the important thing is most of our resource collections are going to give you a list of properties that you can be filtering on. And here we can also see that syntax for filtering on nested properties. So source, resource, URI, source, type, that's going to be included here. Then again, some more examples, but the guide has more details and it may be easier, or there's another way to understand our filtering options. But here we kind of have some examples that are more specific to this resource collection. Sorting, again, is described here. The other thing I want to get to is the error responses, right? So, or I guess we'll start with the responses. So the 200 OK response, we can see our responses for pagination here, offset, count, total, and items. And so then the items kind of contains the specific resource itself, where we can see these properties, the common properties that I mentioned, like ID, type, generation, created at, and updated at. So let's collapse those. So if we look at a bad request example, right, our error response has that status code, error code, message, debug ID, and then error details. And so here in error details, this is an array of error details, and each error detail instance might be one of different types. So bad request kind of has this structure. So the type field will always be there, but then the other part of the structure is kind of different depending on which type of error it is. So for a bad request, you're going to get a list of issues that have like a source, subject, and description to tell you what where there may have been an issue in the request. So if the filter expression didn't work, it might tell you that there was an issue with the query parameter. There's also the kind of general metadata, which just gives you just a key value pair for us to be able to put some information back about what may be going wrong. Retry info, if there's throttling involved, that'll just give you a retry after seconds. And then occasionally there may be a precondition that's failed, which would give you a list of those issues where the preconditions were not being met. But that's kind of the standard error response object. So if we take a look at, not acceptable, it would kind of be a similar structure. And then in error details, it's going to be, one of these options, post likely metadata for not acceptable, or actually it might be just bad request as well. So that kind of shows those common features from our API. So in the next section, I want to talk about the compute ops management resources. And this is going to provide an overview of some of the resources that are provided by our API. This is going to be specific to compute ops management because this is what our application is providing. So this is a complete list of resources that are currently available through the API. And the ones that I've highlighted here in green are the ones I want to talk about a little bit more in the upcoming slides, but certainly the others are also available, and all of them are described in detail on the API documentation that we've just been looking at. So I'm going to just highlight a couple of these, maybe not read all of them, but these just kind of give you a quick blurb, at least in my words, of what each of these resources represent. It's very hard to kind of summarize this all without writing like a whole paragraph on each resource, so I may not have very exhaustive definitions here, but I hope they're at least precise enough. So starting with servers, I'm going to skip around a little bit because I kind of want to go in an order that maybe makes more sensible. So servers is kind of our primary resource. For servers, we have kind of the basic properties, information about the ILO. There's health information, inventory information available there as some of the sub-resources. So that's kind of our main resource of the servers that are active and connected to your infrastructure and connected to compute ops management. Then the next thing is going to be groups and server settings. So groups and server settings can help you manage and organize your servers into groups, and server settings allow you to provide configurations for those servers and associate those with the groups to provide you kind of a policy-driven management approach. And in order to perform actions, once we've kind of got some of those policies defined, whether it's firmware, OS, or other configurations, we can use jobs to perform actions on resources. And we're going to look at jobs in a little bit more detail, but jobs might be things like powering on a server, powering off a server, performing a firmware update. And jobs can also be performed on groups. So not just servers, but groups can also have jobs can run on groups, so you can schedule a firmware update for a group. And I'm sure there's many questions about how exactly that works. When can I stop the firmware update? What happens, right? There's all of those details are kind of there within those features. But the focus here, I kind of want to just highlight what we have available in the API. So the next thing is going to be activities. So as things are occurring in compute ops management and with your servers, there's going to be events and tasks and activities and jobs that are occurring. And so activities is kind of the resource that we have for describing what's happening in the system. And that's where you can kind of see progress of firmware updates, health state changes coming in, alerts coming in, things like that. You're going to see all of that through the activities view. And then the next thing I want to highlight is schedules. Scheduling allows you to schedule jobs, which may be very useful for proactively collecting information or providing, scheduling firmware updates at a specific time, so that you don't have to actively be there to push the button. You can go ahead and set up a schedule, which will basically just turn around and make a REST call for you to go ahead and perform some operations. So that's a nice feature there, to be able to schedule firmware updates and other jobs kind of for a future point in time. And the schedules can also be made recurring if that's necessary. The last thing I want to point out a little bit is webhooks. So webhooks is a relatively recent feature that we added. And this is an ability for you to receive events to your own HTTPS endpoint from COM about events happening, from compute ops management about events happening within the system. So this requires a little bit of setup on your side to set up a publicly accessible HTTPS endpoint. There's a detailed guide. We'll get to that in a second that I'll talk through about there a little bit. So just kind of rounding out the rest of these, we have saved filters to kind of help you. This is mostly for resource restriction policies, if that's something you're familiar with. There's some external services that we can work with. So ServiceNow is one of those external services that we can integrate with. So there's some configuration for that. Of course, we got to have firmware bundle information available so that we know what the firmware updates are that are available for our servers. Job templates, these basically describe the jobs that we talked about, that I mentioned, that we can create. Metrics configuration, how often and when we collect metrics. There's reports. The main report that we have now is our carbon footprint report, showing you your carbon footprint across your server estate. That's under the reports resource. And then user preference is just managing notifications for getting emails about alerts and kind of daily health emails that you can subscribe to with that user preferences API. So let's take a look at some of these in more detail. I may have already covered some of this, so maybe we'll go through this section a little bit more quickly so we have some time for a demo. So servers, again, basic properties about the server, health and inventory. There's some sub-resources for servers, which is alerts, inventory, notifications, and adapter and switch port mapping if these are connected to a switch that's being managed as well. The API version here, currently V1 Beta 2. Okay, doesn't want to do that, so we'll do this. So groups and settings, I kind of stuck these together again because they provide organization, policy, and settings configuration for your devices. And groups have two sub-resources. One is the devices. So as you add devices or servers to a group, those devices are part of the group, and you can kind of see some basic information on those devices, including their serial number, product ID, and a little bit of information like that. Compliance is also a big piece of this resource. So understanding whether all the servers and all the devices in the group are compliant with the policies that are specified by the group in the settings. So there's a compliance sub-resource to tell you about that. Groups are at version V1 Beta 2, server settings are V1 Beta 1. Jobs and activities. So jobs perform actions on resources, whether it's groups or servers. Activities are the events and tasks that we talked about. And this is where I want to kind of point out the job definitions page that we have to describe the jobs in more detail. So this is one where we're going to actually jump back to the browser. And let's take a look at this jobs definitions section. The reason this is here is because jobs are identified. So first of all, we have a list of available jobs. So these are all of the jobs that are currently available. And this is a quick summary table with the name, description, resource type, template ID, and required data. So what is the template ID and required data? The template ID is a durable ID for that job. So this ID is going to be the same across all of our instances of compute. So anytime you're interacting with compute ops management to power off a server, this is the template ID that you'll need. So this kind of is the job template And then that describes the additional properties that we may need for that particular job. So each job has kind of different required data that it might have. And this is a summary table. So you can come back here quickly to grab the right ID if you're already familiar with the job and kind of how the rest of the details work. If it's kind of a first time or you're not sure what all needs to be done. So, if we take a look at group firmware update, that's a pretty complex job. So we can go ahead and click on that. And we see that, each of the jobs kind of have their own detailed page. So again, job template ID is provided. We give a section on how to create a job. So these are kind of the basics, right? We need that job template URI or ID. The resource that we're operating on, in this case, it's going to be a group, and then data, which is the additional data that we need for the a particular job. And we'll see an example of creating a job, hopefully in the demo. But here's a case where for this job, right, there's a lot of settings that we can decide. Which devices in the group do we operate on? Do we want to perform updates in parallel or not? Do we stop when there's a failure? Are we allowing downgrades? Do we want to install software drivers? Do we want to turn the servers off after we're done? Or do we want to run a prerequisite check that if it fails, it doesn't work? So there's kind of a summary table of options that you can provide, and then that's described in more detail. So I strongly encourage you, before kicking off jobs, you'll definitely want to come reference this, find the job that you're looking for, and then read more about it to be able to successfully kick off that job and understand what the different properties mean, and kind of how to control that job. That's what this documentation is there for. So with that, let's go back to schedules. So schedules, I already talked about most of that. Is scheduling a REST operation. There's a sub resource here for history. So this will show you the actual run of the schedule. So when the schedule runs, it'll create a history entry, and then you can see kind of the status of what that operation did. Was that operation successful or not? Not the end operation, but just kicking it off, right? It might not tell you whether the job ran or not, but it will tell you whether it created the job successfully or not. That's kind of what the history section is going to tell you. V1 beta 2. And then webhooks, this is where you can register your own HTTPS endpoint to receive events. And again, for this one, highly encourage you to read the webhook guide, including prerequisites, because there are some prerequisites to set up, because understandably, when Compute Ops Management is posting events to an endpoint that you're hosting, we want to make sure that we're establishing trust in both directions. So that's described there in great detail on how that works to ensure that, and what the event webhook payload looks like, how you can subscribe to events, what events you get. All of those details are provided in that guide. But this is a great way to get notified about events that are happening within Compute Ops Management. And similarly to schedules, I realize this slide's out of date now, so I'm sorry, I got distracted. There's a delivery sub-resource. So as we deliver events, you can see a history of the deliveries. So whether they've been successful deliveries or not successful deliveries, we'll be able to see that. Webhooks is a V1 beta 1, and this is under a new API group, Compute Ops Management, which the rest of our APIs will be adopting soon as well. But just wanted to point that out here, that here the API group is Compute Ops Management, kind of in this instead of just Compute Ops. So with that, I think we're kind of ready for demos, but if there's any pressing questions that I may be able to answer now, let me look at that. Or in the chat. Okay.
I think I've got most of them in the chat.
Yeah, I was going to say.
Excellent. Thank you, Blaine. All right. So let's go back over here. So for getting started, right? How do we get started? Let's go back to this page. What you're going to want before we get started is we need to know how to log in, how to get an access token. So under services authentication, it describes in detail how you're going to be able to go ahead and get your access token. So I am not logged in anymore. So let's log in real quick. Is this workspace? Okay. So if I come in here and I say manage workspace and I go to API, you can create API client credentials here, and that's what you're going to want to do to be able to access our API. So when you create a credential, you have to select which provisioned application you're using. So in my case, because I'm in a demo account, I provisioned our application in all of the 3 regions that we support. And you may have other applications here for other services that are part of your workspace. But you can come in here and select that and then give it a name and go ahead and create the credential. Since I already have all 3 of these, I can't really create an additional one at this point. As you look at this credential, When you create a credential, it's going to give you a client ID and a client secret. The client secret is only going to be displayed on that initial screen, so you're going to want to save that someplace secure. The client ID is displayed here, but again, you're obviously also going to want to save that. So all of this is a OAuth 2 authentication flow where you provide your client ID and secret to this common endpoint to then obtain a bearer token that you will then use with the APIs. So all of the APIs require a bearer token, and the bearer token in this case is going to be specific to your workspace, so whichever workspace I'm currently in, and the specific application I'm targeting, and then whatever permissions I've been granted within the system, those will apply to my bearer token. So I could go ahead and generate an access token here if I wanted to, if I provide my client secret. There's also sample code here on how to obtain an access token in Python and curl, for example, and you can actually even select like your client credential and it'll fill that in. If you paste in your client secret, the code blob will be ready to go. But what I like to do is I use Postman a lot. So that's what I kind of want to show you today is kind of how I use Postman. So in Postman, what I've done is I've gone ahead and created a bunch of variables. I love doing this in an environment. So this is, I'm in a specific workspace, but I have an environment here for the user experience demo. And I've created a bunch of variables for each of our production environments, as well as one of the demo environments that I may use for a couple of example APIs, and then obviously the client ID and secret as well. So now I can reference those throughout the rest of my collection. The other thing that I've done is I've actually imported our collection. So at the beginning, I mentioned you can download the Open API spec. If you download that, you can just import it directly into Postman, and that'll be able to pull up all the APIs for you here, which is really nice. It's a great way to get started quickly. So within my collection, I can go to authorization. My authorization type here is going to be OAuth 2. So that's what I've already pre-selected. And then here you can, in this configure new token section, you can give kind of a name of the token so you can kind of remember what the token is. You provide this single sign-on URL that we saw on the website of where to obtain a new token, and then the client ID and secret. And since I don't want to have to type in those each time, that's where I'm using those variables that we saw in my environment to kind of fill those in here. So this is the syntax that Postman uses for a environment variable. So that's my client ID and secret. And then all I have to do is hit get new access token, and it automatically completes that process in the background. Proceed, it kind of shows me the bearer token here, and then I can say use token. So now I have an access token for our US West API. And what I want to do with that is I'm going to go ahead over here and go to list groups. So this is going to be our, so the host name here we can see is US West 2 API Compute Cloud HPE.com. And then we've got our API group and our version, and then it says servers and groups. A little bit confusing, I think, because I've been working on some changes. Let me make this a little bit larger, so maybe easier to see for everyone. That's maybe too large because I need to be able to click around. So then I don't need any of the parameters right now that we talked about, but under authentication, because this API is part of my collection, I can inherit the authentication from my parent. And what that means is it will use the token that we used generated over here as part of this request. So if I send this request, hopefully, fingers crossed, it will go through. Why is that so slow? I was telling everyone that I have to use this joke at some point, right? When you do a demo, this is how it goes. So let's try. Why is that not working? Okay, let me. Hopefully there's not an issue with our backend infrastructure. Okay, this worked. Okay, great. So I switched to just a different tab. Maybe it just needed a little bit of time to get started. So in this particular case, I don't have any resources here yet, but we can kind of see that coming back. So what I really wanted to do is just do a simple create for a group and just kind of show a couple of examples, right? This won't be super exhaustive because so let's say we want to go ahead and create a group. So I guess I have my API host name here. I'm going to create a post. In the body, what I want to do is provide a name and a description. And that's kind of the minimal thing I need to get started to go ahead and create a group. So I'm going to go ahead and do that. So now we can see 201 created, and we can kind of see the response that came back for the group. It kind of filled in a lot of other values with default values, and we can see, we've got resource URI, the list of devices created, updated at, and generation, and things like that. So as an example, if I want to, so if we go back to the list, why did this not, okay. Let's just go back to the list of groups. We can see that group coming back. So now we've got, count 1 items that, and then, these are not super interesting examples right here. But if I say offset 1, right, I'm not going to get anything back because there's just 1 item in the collection. So that's that. I think what's going to be more interesting is if I get a list of activities, because here I can actually show a little bit of the filtering. So I'm going to go ahead and US West. I was working on a different system yesterday as well. So we're going to go ahead and get a list of activities. Now we have 68 activities in this system. Because I haven't done a whole lot with this particular account, a lot of these activities are going to be related to firmware. Although we can see our most recent activity was actually me creating this group. So we can see that, it says group created. That's kind of the key. The message says group created in Compute Ops Management. There were no settings or anything else was configured for that. And prod Oregon is the group that I had just created. So we can see that. But the reason I want to show this is because here we can kind of see, let's see some of the examples of filtering here, right? So if I want to start at offset 5 and get the next 10 items, then we can add those 2 query parameters. And instead of the 68, we're going to go ahead and we're starting at offset 5 and count as 10. So now we should hopefully only have 10 items in here, right, instead of a bunch. So I'm just going to collapse some of these to show there should be roughly, 10 things in here instead of all 68 coming back. Then the other thing I want to show here is kind of the filtering example. So we're going to go ahead and actually, before we do filtering, let's go ahead and get the whole list of activities again. So under the firmware activities that we have in here, I'm going to find one. So firmware patch added, that might be a key that I'm interested in. So if I say key equals this, so we're going to filter down to those. So instead of the 68 that we have, we're going to get back, 19 activities here that all match this particular key. And as I said, right, the filtering language is pretty expressive. So there's more that you can do here with those filters. But this is where, we can see the total is now 19. And so, even if I say like limit 10, then what we're going to see is, count is going to be 10, total is 19 instead of 68 because the filter is getting applied as well. So the last part that I want to show is I want to just very quickly, this is going to be a super quick demo for creating a job. And this, I don't know why it sometimes shows me that. That makes it harder to type down here. So we're going to go ahead and switch to demo. So this is just going to be a different host name in a demo environment where we have some servers. So I'm going to go ahead and grab a access token for that. And I want to use that token. So here I have I'm creating a job, and this is the ID for the power off job that we saw at the beginning. And then we can also see the resource URI for a particular server that I have in that environment. And for powering off, I can provide a property, what kind of operation I want to do. In this case, I want to do a graceful shutdown. So I'm going to go ahead and hit post and then create this job. So it's going to go ahead and create the job for me. It's going to start in the running state, and we can kind of see the operation and the request payload that we have. So if I, let's see, so the resource URI of the job is this. So if I want to see the progress of the job, I can go ahead and use that. And in fact, I'm just going to copy it because I want this to use the thing. So I had this request yesterday with a different job. So we're going to go ahead and paste in that job ID here. So now we're doing a get on that particular job instance, and we're going to see what happens. So in this case, my state is complete, and it says the server is already powered off. So that's great. In this case, my server was off. Like I said, this was kind of a simple example, but you can see kind of how we create a job. And again, as the reference, as we saw, jumping back all the way to here, the server power off, this is where we saw, graceful shutdown or force off. Those are the 2 options. And this is kind of the job template ID here. So that's kind of how we put this request together. There's also examples on each of these pages. So if you're ever unsure and not know how to stitch one together, we provide examples. So this is very similar to what I did in Postman just now. Basically, we provide the job template ID, a resource for a particular server, and then graceful shutdown as the operation type. So with that, there might be one last question. I think Didier said we're going to try something new here, which is a little quiz. So I'm going to go back to my slides real quick. I have a quiz here for everybody, which is how many regions does HPE GreenLake for Compute Ops Management support? So we got 1, 2, 3, 4, 5 as our options for that today. All right, I see a lot of people are getting this one right, which is great. About half the participants have responded. Okay. Cool. Okay, I see a few more responses trickling in now. If we did this as a poll, it would be very easy to just review everybody's answers.
I'm not sure what the difference with a poll between a poll and a quiz, but we'll find out.
Exactly. All right, so with that, any questions that I can answer for you right now? I will say my email address is here, but if you actually have an official support case, I would recommend that you maybe not start with me. There's a contact us link back on the main developer portal under the guide section. So if you actually have an issue with an API that's going to be specific where you need to provide information about your workspace and et cetera, please follow the help process. But if you have general questions about the API or want more information, do feel free to contact me and I can point you in the right direction, but shouldn't directly jump to me as a developer for support. I want to make sure that flows through our support process because the team there is capable and definitely ready to help you with those questions.
Thank you, Sebastian. I have just launched the end of session poll. I'll be very happy if people can quickly spend just a few seconds answering these 3 questions. So we know if this was useful, if you want more of these talks, and thanks for asking all these good questions. I think Blaine did an incredible job in answering almost all of them. Thank you, Sebastian. That was a great session. And I don't know, I see there's 2 more questions open. Do you want to maybe, do you want to take the last 2 questions maybe?
Yeah, let me.
From Ron and Eric. Oh, Eric is just thanks. Thanks, Eric.
Okay. Yeah, so can we chain multiple jobs in a single API call? So the answer to that is no. The jobs are going to be kind of creating one at a time. And the other thing about jobs that I want to point out, actually, this is a good question. So the system will only let you run one job on a resource at a time. So it will queue up or put the other jobs in a pending state. So if you have a server, for example, you can appreciate that if we have a firmware update running, we don't want to just power off the server in the middle of that. So the jobs are going to be sequenced by that resource. And so if you do create, you can create the job, but it may enter a pending state and not be running while a previous job is running. And you can take a look at the list of jobs and filter by the resource ID to see which jobs may already be running. But for sequencing, if you want to sequence operations, you probably want to look at groups and kind of grouping servers, and then you may be able to perform firmware updates on a group of servers if that's what you're interested in. Otherwise, with scripting on your end, you can probably sequence the jobs as one completes. You can kick off the next one and kind of iterate through that. Let's see the other questions. Okay, I think they're all answered now. So
yes, they are.
Excellent.
Thank you. Everyone, thank you for attending. Sebastian and Blaine, thank you for the session. I think it was very good content. And everyone, see you in 1 month for the next meetup or the next mention now. Thank you very much.
Right, thank you.